One way to multiply expressions is by using the distributive property. We can represent that multiplication using an area model. And using the area model, we can see that by distributing the 4, we can find a combined area of 4x plus 8. If we go the other way with that process, in other words, start with an expression and write it as a product of its factors, we're doing what's called factoring. When we factor an expression, there may be more than one way to write an equivalent expression to the original. In this case, 4x plus 8 is the same as 1 times 4x plus 8, or it's also equivalent to 2 times 2x plus 4, or it's also equivalent to 4 times x plus 2. You can see from the area models that each of these expressions has the same area. While the expressions all are equivalent, if we're asked to factor the expression 4x plus 8, then it's the expression at the bottom, 4 times the quantity x plus 2, which we're going to consider the factored form of the original expression. That's because 4 is the greatest common factor of the two terms, 4x and 8. Thinking of multiplication again, we can see that if we multiply two binomials, we're still using the distributive property, and sometimes we use the acronym FOIL to describe the 4 multiplications that we do to multiply the binomials. If we look at an area model for this multiplication, we can see that there are 4 areas within the large rectangle. Those are the 4 areas we're going to find by doing our 4 multiplications. We'll start by multiplying the first terms in each binomial. So x times x is x squared. Then we multiply the outer terms. X times 2 is 2x. The inner terms, 5 times x, gives us 5x. And finally, multiplying the last terms in the binomials, 5 times 2, gives us 10. Quite often, we'll see that the outer and inner terms are like terms. They have the same variable raised to the same power. And in that case, we can combine those like terms. So 2x plus 5x is 7x. And so the final result of our multiplication is x squared plus 7x plus 10. Suppose we start with the trinomial, and we'd like to know what the two binomials were that were multiplied to give us the trinomial. Well, in order to figure that out, we'll remember that in order to multiply those binomials, we would have used FOIL, the distributive property. We can also take a look at our area model to see if that will help us figure out what's going on in this multiplication. So first of all, if we multiply the first terms together in the binomials, we'll end up with the first term in the trinomial, the x squared. Now looking at the area model, you can see that something times something is x squared, and there's really only one possibility for that. It would have to be x times x. Now we'll focus our attention on the last term in the trinomial. It's a 12. And that 12 comes from multiplying the last terms in each binomial. Now here's where it gets interesting, because there's more than one way to multiply two numbers together to get 12. It could be 1 times 12, or 2 times 6, or 3 times 4. So how do we decide which of those combinations is the right one? Think of it this way. It's kind of like solving a puzzle. We've got some pieces to put together. We just have to find the right ones to make the picture come out all right. So let's just start from the top. We'll start by thinking of 1 times 12, and we'll look to see if the two missing numbers that we're looking for, the 1 and the 12, will give us the right middle term for our trinomial. It's just a puzzle. You'll see. So let's take those numbers, 1 and 12, and let's put them in the picture. and see what we've got. 1 times 12 is certainly 12. But now we can look at what we get for the area of those other two rectangles. 12 times x is 12x, and x times 1 is 1x. So that means our outers and our inners, 1x and 12x, would combine to give us, oh dear, 13x. That's not right. We need 7x. So we can eliminate 1 and 12. So let's move on and look at 2 times 6. 2 times 6 definitely is 12. Now, what would that give us for the areas of the other two rectangles? Well, 6 times x is 6x, and x times 2 is 2x. So 6x plus 2x, that's 8x. Still not the 7x we're looking for. So we can eliminate that possibility. Now we're down to one last possibility, 3 and 4. If these two numbers don't work, then we can't factor x squared plus 7x plus 12 anymore, and it would be considered prime. But let's give it a go. This might be the right combination. Okay, 3 times 4 definitely is 12. Our other two rectangles have an area of 3 times x, which is 3x, and x times 4, which is 4x. So our outers and our inners are 4x and 3x. Hey, we've got it. 4x plus 3x is 7x. So we found it. We found the right combination. That means we've got our two binomials figured out. X plus 3 is one of our binomials. X plus 4 is the other one, and if we multiply those together, we get back to the x squared plus 7x plus 12. Yeah, it's just a puzzle, right? You try all the pieces, you find the ones that work. Let's try one more. We'll try to factor x squared minus 4x minus 5. Once again, we'll use our area model to make some sense of this. And we'll also assume that if this factors, it factors into two binomials. Okay, here we go. The two binomials would get multiplied using FOIL. The first times the first would have to give us x squared. And the only way we can get x squared is to multiply x times x. So that part's easy. Now the puzzle part. The last times the last has to give us negative 5. Now, there's not a lot of possibilities here, but because that's a negative, we have to consider that. In fact, we could get negative 5 as a product of 5 and negative 1, or a product of negative 5 and positive 1. So we've only got two possibilities to check here. Yeah, only two, so it's not going to take us quite as long. So let's see, the outers and the inners will have to combine to give us negative 4x. Let's just try the first one. Let's try the 5 and the negative 1. So let's see, 5 times negative 1 is negative 5. The two missing areas for the outers and the inners are 5 times x, which is 5x, and x times negative 1, which is negative 1x. So our outers and our inners, negative 1x plus 5x, that adds up to positive 4x, not negative 4x. Close, but not quite. That's no problem. We've got one more thing to try here, which was negative 5 and positive 1. So negative 5 times positive 1 is negative 5. So far, so good. The other two areas are negative 5 times x, which is negative 5x, and x times 1, which is 1x. And that would give us outer of 1x, inners of negative 5x. Those add to give us, there we go, negative 4x. We found it. So we've got our two binomials figured out. Now there's only one other thing that we're going to do here. One of our binomials is x plus negative 5. We're going to write that as x minus 5. Looks a little bit neater to do it that way, but it means the same thing. Yeah, see, it's just a puzzle. You try all the combinations that you've got, and if the trinomial will factor, you will find the combination eventually.